Hello, everyone. Fraser's still typing up our intro, and I'm just making sure everything lined up well enough. I am back down in my studio, which means that I have to redo all my settings again, but the studio computer got plenty of testing last week as I streamed NASA mission after SpaceX mission failing spectacularly. I was not a fan of anything failing. Like, was it last Thursday that started with Ariane 6 successfully flying their second mission with that brand new rocket? Then Intuitive Machines attempted to land for the second time on the moon. Failed. Missed their... they missed their landing site by 250 meters. Ended up in a dark crater, having fallen over, taking a picture of the Earth rising between their legs, which is not something anyone really wants to see. Yeah. That was terrible. Yes. So it made me think of that Monty Python sketch with the Galaxy song, and I have not been able to get that out of my brain, and I don't like that. And then, of course, there was the air traffic chaos of Starship 8 that blew up at pretty much the exact same point in their flight between Florida and the Bahamas, creating a massive corridor of thou shalt not fly there, causing all sorts of chaos. Yeah, so Florida had to close all of their airports. There were planes stuck circling for an entire hour, worried about fuel. They were told they couldn't cross the no-fly corridor, which was like hundreds of miles in the east-west direction, unless they declare an emergency and put their plane in danger because of stuff falling out of the sky. Yeah, it was a bad day, and then I ate my feelings. It was just one of those moments. Sometimes that's all you can do. Like, space is hard. We know space is hard. Yeah, McDonald's was definitely involved. You shouldn't be. Say something? No, apparently they can't. Hold on. Why? Why is that happening? The audio says it's there. Let me delete it and put it back. Say something?
Can you hear me now?
Yeah, apparently I needed to delete your audio and put it back again.
Right, that makes sense. Apologies for the bright red marks on my face. My doctor wanted to blast away things from my face.
Oh no.
Yeah, you know how it goes, getting old.
Yeah, it's for the best.
Doctor wants to, we haven't moved to like, let's remove things surgically, but you always, need to keep a close eye on anything that appears on your face. So, so I had a week.
Okay, so yeah, I'm so glad you're back. Let me actually set up so that I can screen share your new site.
Oh, that'd be great.
It's fabulous. It's just going to take me a hot minute.
Yeah, so what happened was, and this is like the short version. We're going to do like a longer video this week, but the gist is that earlier, I guess last week today, a week ago today. There we go. A week ago today. One of my writers reached out and he's like, I can't access the website. What's going on? I'm like, I don't know. Let me check it out. And I went in and I could also not make the website go. I was able to access
Which
it.
Which induces
at the
panic.
Command.
That is the most panicky thing.
Yeah. I accessed at the command line level, but I couldn't like make the website go. And so I tried restarting the website. That didn't work. I restarted restarted the server. That didn't work. I went to my webmaster. He was like, oh, this is no problem. Hold on. I can't make it work. So we're like, oh God, okay. He's like, I think we're gonna have to go to one of the backups. No problem. We go to the backup's corrupted. Okay, we go to the previous backup's corrupted. We go to the previous backup's corrupted. So all of the live backups that we had, snapshots of the server, they were all corrupted in the exact same way. None of them were going to work. So that's okay, because we have a second method of backups. But we forgot how we made that second method of backups.
Oh no.
And so we checked the way that we thought we were making the backups, and there were no backups there. I'm like, oh God, what's going on? And so then he was like, okay, well, I think I can get the database files and all that off of the server, and we can put it somewhere else, and you can start working with that. And so he did that, and it was going to take him a few hours. And like since then, I found where the other backups were, and there were tons of them. They were totally fine. And it would have been super easy if I just had remembered, because it had all been so automated. Like we had a script that was dumped in the database, storing it into this file system. Anyway, but there's a thing that I've been wanting to do, and that is that the revenue on the ad revenue on Universe today has just cratered, like just gone to zero. Over the last, not zero, but essentially we're down about 90% over the last 3 years. And there's like two big reasons. One is that now Google no longer sends you traffic. So if you go to Google, you Google anything, you get a like a AI summary at the top of the page. And so that alone has knocked off the vast majority of search engine traffic. And then the other thing is that because of all the AI slop that's out there on the internet, you get just a bottomless amount of supply. And so the ads are no longer very targeted. The ads are garbage, political attack ads, penis pills, things like that. And so you get a sharp decrease in the amount of ad revenue that you get. And so advertising has gone from, the amount that I make on ads for Universe Today, pay the salaries of the people that write for us, is down 90%. But we have been growing our Patreon over the last 4 or 5 years. And we're at the point now where we're about 80%. If you take the Patreon amount and you take the money we make on YouTube, it's about 80% of the revenue that we were making back in the good old days of advertisements. And I hate having ads on my website. Like I just hate it. And they're gross and they're invasive, and they hit you with cookies, and the amount that we're making is just decreasing and decreasing. And we're using this old technology, WordPress. It was very slow. And so I've just been, all I can think about for the last 6 months is how am I going to get off of this web platform and build something new that's clean and has no cruft on it. And so this was the moment. Right, this is like the straw that broke the camel's back. It was a moment to go, okay, fine, we're gonna do this. Like I think I can pull this off. We're gonna switch to this new system. And so we redesigned. So over the course of 2 days, I set up a new server, installed a software platform that I'd never used before that builds a static version of your website, completely redesigned the front end of the website, and then re-implemented every single piece that I still wanted to bring into the new world, built all of the user accounts, migrated all of the content from the old site, trained the team, and got operational again by Tuesday night. And the new site has no ads, has no JavaScript, has no trackers, has no anything. It's just words and pictures in the simplest possible HTML. And it's entirely being done thanks to the support of the patrons. And so we are now independent space news reporting agency that is funded entirely by our patrons and a little bit of YouTube revenue. And I think, unless something really weird happens, I'll be able to complete this transition. Like when I tell this story on our YouTube channel, I hope people will come on board and join our Patreon, and then that should do it. And then we're done. And then I don't have to think about ads. I don't have to think about algorithms. I don't have to think about all I have to think about is how can we do the best space news journalism that I can for our audience. And that is so amazing. And I think the thing that people are going to see is that the media landscape is about to get vaporized. that if, me, a guy who works from his couch with a team of writers who are, who could be paid more if I had more money, and that's all our expenses, and then a couple $100 a month in server expenses. Like, that is the entirety of Universe today. And when you compare that to the other kinds of, even in this media space, but just all media in general, they're all dead sites walking. Their traffic is gone, their ad revenue is gone, that there's no way they can support their existing financial models, and they don't have that sort of grassroots level support that we do at Universe today. And so I think, like, it's not just us, but just don't be surprised if the things you love are now about to start disappearing, because I couldn't figure out a way around it except for to get funded directly. Like, I could have done a paywall, but yeah. So that is where we're at.
Awesome. And I showed off your site.
Oh, great.
I coughed into my microphone, which I feel bad about. I'm sorry. I am still fighting bronchitis. Yeah. It is so much better than it was, but my lungs are fragile little snowflakes.
Yeah. Yes.
So, yeah.
Yeah. So that's where we're at. And
it's awesome.
It feels really good, and also is really scary, because if I can't pull this off, then I will have to shut the website down. Right? Like, that's the reality, is that if I can't make the readers, if I can't encourage the readers to pay for the content, then I'm going to have to shut the website down and just focus on the stuff that the videos that I make, the podcasts that I make, and not provide text content anymore. So that's what's up for grabs. That's the risk. And that's our journalism, right? And so now it's just instead of the journalism from all of the writers, it's just the journalism that I can pull off with Anton and Chad helping me make the videos.
Yeah.
Which would, like, I would still be working hard and producing a lot of stuff, but I feel like the writing from the writers, the journalism that we do, that's the crown jewels of our organization. So that's the risk, but I think that the reward is that we're independent. So even more independent than we were before. So.
It's really been cool watching it come together, and I'm so glad you didn't keep that black background. I just have to say that I had this moment of.
Oh, it depends on when you can set it so that it goes either color.
Oh, so when I look at this after dark, it will go to black, since I have automatic light dark on my computer.
Yeah. So it's got so it can do I look at the dark version.
Okay.
Yeah.
Okay.
Alan's saying there's a 404 error on the newsletter page. Yeah, because when you submit your email address to the newsletter, then it responds with a 404, responds with a page, and the page doesn't exist. So that's on the list. We'll fix that. There you go, and a typo in the paragraphs below the "We Hate Ads" pick. So there you go.
It takes time to fix everything, but
I've got a huge list of things to fix. Like, it's probably still a list of. We've only pulled in content as recent as 2019, so there's still another 20 years of content to bring into the database.
Yeah.
So there's a million things to do, but all of the freak out urgent things were done, and it was hilarious, because I was just like sitting in the couch, and then every 5 or 6 hours, Carly would be like, "Are you hungry?" Yes. So she like made me a burrito, put it in front of me.
I have gone through that. At one point, Fraser was like, "We could probably record Thursday," and I was like, "No."
Yeah, I probably could have, but no. I'm glad I didn't, just because I was in the zone, because then you're in the kind of the cleanup, and then the issues that aren't mission critical, but you just can't get them out of your head, like managing the caching system and all that. Right. So anyway, that was my day, and I think we are. It's at an interesting inflection point in the future of media.
Yeah.
And so I'm the canary in the coal mines for everybody watching the things that are going on out there.
And it occurred the week before LPSC, so my brain was like, all the good space stuff is going to hit this week. You need to be live.
I know. And we're already gearing up. So I've got one writer who is going through the LPSC
Abstracts.
list of abstracts with a fine-tooth comb, pulling all the ones that we're going to want to report on, and then we're going to start putting together stories from the LPSC. It's a gold mine every year.
It really is.
Yeah, and nobody else covers it. It's kind of amazing. All right. So there you go. That was my adventure. I'm going to give a sort of a shortened version in Astronomy Cast, and I'm going to put out a big video on the YouTube channel where I sort of explain what happened.
Definitely.
And so on. But that's all coming.
All right. So are we ready-ish?
Yeah.
Okay, I'm pressing record on my audio. I am pressing record on the video. I'm unburying my notes, which were under my keyboard.
Okay.
We're good.
We go. Astronomy Cast, episode 747, Rogue Planets. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am 90% better than I was when my bronchitis was at its worst. But I'm still going to cough, and I'm still very grateful for Rich. And any of you watching this live, it's definitely a no makeup kind of experience. So
for both of us.
Yeah. You had one hell of a week last week.
I really did. Yeah. So for people who know, we didn't release an episode last week, and that was because I was too busy to record Astronomy Cast, which is weird because it doesn't take much time. But yeah, my website went offline hard last week, and backups were failing, and we had to rebuild the website on a new server. And I decided to sort of live a dream that I've been planning for the last 6 months or so, and that is to remove all of the advertisements from the website and go 100% supported only by the patrons. And because like the ad industry is just in free fall, search engine traffic is being no longer delivered by Google because you get the AI slop at the top of the search results. And so, it was destroying my business. And at the same time, we've gotten more and more patrons coming on board. And so I was able to I said, that's it, I'm done. So no ads on the website. I want something that's just clean, that a teacher can feel great about showing off in their classroom. And we are 80% able to afford this with our current run rate of writers. And my hope is that over the next couple of months, as I sort of tell the story of what we're doing, we'll be able to fill that gap. And then we will be a completely independent space news reporting agency that isn't concerned about advertisements or stats or Google or any of that. And so if that's exciting to you, if you want to support us, go to patreon.com/universe today. And we're going to have more information about like what actually happened over on my YouTube channel shortly. And I think hopefully give people a fairly dramatic understanding of what's happening to the media industry from someone who is inside of it. And, I'm the canary in the coal mine. I am the person who runs very lean, and yet it was unsustainable for me.
Yeah.
So hopefully we'll get to this place that is sustainable forever. And I can employ people and keep going and report and don't care about what happens outside of just making sure that we tell good space news stories. So I'm excited. I'm freaked out, but I'm excited.
And I've enjoyed watching just where you've gone. The images are big. The site is bold.
It's
what you're
clean.
doing
There's no ads.
amazing.
There's no JavaScript. There's no tracking. There's no Google Analytics. There's no sponsors. There's nothing. It's just pure pictures and text. And it is, 1/10. Each article is 1/10 the file size that it was before, because I've been able to remove all that and just focus on just the simplest HTML implementation. Yeah. So it's pretty cool. Most planets orbit stars. That's the rule, right? Well, maybe not. In fact, the vast majority of planets could be floating freely through the Milky Way. Today, we're going to talk about rogue planets. And we'll talk about it in a second, but it's time for a break. And we're back. All right. So rogue planets.
Yeah.
What is a rogue planet?
So scientifically, they get called, and I always call them rogue planets, so I have to look at this. They're technically planetary mass objects, independent planetary mass objects, or free-floating planets.
Right. Free-floating planets is the term that I'm most familiar with. But I agree. I like rogue planets. Although that opens up the mistake of rouge planets, which I get in the comments where people are talking about that. And
That's true.
Just to be clear, we're talking about rogue planets, not rouge planets, which are not a thing.
There's something I paint, but that doesn't mean they're real.
Yeah, maybe. Yeah. Okay, so free-floating planets, rogue planets, and so what are they?
These are objects that are less than 13 times the mass of Jupiter. They've been found as small as the planet Earth, and they exist out between the stars. We have found them in two different scenarios. They of course exist just hanging out in the galaxy. They were first discovered with microlensing. There was a group of them back in 2011 of 474 microlensing events. 10 of them were deemed to be planetary mass objects.
And so for people who don't understand what a microlensing event is, what's going on? How are astronomers making this observation?
So teams look at dense populations of background stars. In this case, they were looking at the Magellanic Clouds. And as a object orbits around the Milky Way and passes in front of one of these distant stars, its gravity will cause light beams that were otherwise not directed at the planet Earth to get bent into our field of view. This is a gravitational lensing event. And because it's just a star or a planet that's doing this gravitational lensing, it's called a microgravitational lens or a microlensing event. So it's just something small using its gravity to magnify light.
And so like an astronomer will be watching a field of stars, and then one of those stars will brighten
in a very characteristic way that is a sharp brightening and a sharp decrease. And the amount of time and the amount that it gets magnified is related to its mass and its orbital parameters.
Right. That's incredible. So they're not seeing the planet.
No.
They're seeing this very well understood brightness curve of the star that is telling you that the equivalent of like a giant glass lens floated in front of the star and focused its light at us for a second before drifting on past.
And we've seen examples of star does the microlensing, and then there's a secondary, much smaller, different amount of time microlensing event that we attribute to planets.
Right.
So we were prepared.
You're getting the star, then the planet.
Yeah.
Yeah.
And then they've been finding, like I said, that first 2011, it was 10 out of 474 events were driven by planets. And a number of these have been found since then. This is how they figured out one of these objects is Earth-massed. We're not going to be able to see a random Earth-massed object flying through the galaxy unless it's very nearby. But its gravity can do things that we can see using background light.
So I did a story on rogue planets and how they did a survey for rogue planets using the NEOWISE telescope. They did a survey for just looking for planets in the solar system, and they couldn't find anything Jupiter mass and so on out there in the outer solar system.
Yeah.
Still leaves the possibility of Neptune-sized objects. That's the Planet 9 possibility.
Yeah.
But they said, like, if there was a rogue planet, we wouldn't see it within about 1,000 astronomical units. So really, until we just don't have the capability right now to see objects planet-sized floating relatively nearby the solar system.
Yeah.
We need that microlensing strategy. And yet there is another way that these rogue planets have been found. And
Yes.
we're going to talk about that in a second, but it's time for another break. And we're back. All right, so what's the other way that we've found rogue planets?
So looking at star forming regions, particularly Orion in the infrared, where these are small, hot objects, planets give off the bulk of their light in the infrared, we have found, I wasn't part of this, you weren't part of this, but astronomers have found all these different objects, particularly binary objects that they have called jumbos, which is Jupiter mass binary objects. And what's weird about these is they have velocities that are consistent with the velocities of the stars in the open clusters and star forming regions that they're looking at. So here are these objects that aren't orbiting stars, that are clearly planets, in star-forming regions with star-like velocities.
And those were first found by Hubble and then confirmed with these recent
JWST.
observations with Webb. And I mean, they found hundreds.
Yeah.
They found hundreds in the Saturn range, the Jupiter range, but as you said, all the way down to I think it was like a sub-Saturn into sort of the big Neptune range.
Yeah.
Well, those Earth ones, those come from the gravitational lensing events. But there's got to be more of them further down the size regime, because that's sort of like how the commonality of different mass objects work. So chances are we'll find plenty more if we get more powerful telescopes. So you've got, and then you said these jumbos, right? Like I forget the number, like 19% of something of these objects are orbiting one another. So
Yeah.
you've got two Jupiters in orbit around each other, free floating in the Orion Nebula, nowhere near a star.
Yeah, the initial survey of these found 9% of the free-floating objects were actually two objects.
Yeah.
And so that also broke our minds. The original expectation was that these rogue planets were things that got yeeted out of solar systems via some sort of a three-body interaction, via some sort of violent incident that just was like, and now you fly away. Now, the thing about these kinds of violent interactions is you then, as we're used to seeing with stars, end up with something with a high velocity. When we see high velocity stars, we know it's something that got yeeted through a multi-star interaction. So when we start seeing binary systems, it's like, how does that even happen? How did those not get torn apart?
Right, like you can understand one getting kicked out.
Yeah.
A single planet getting kicked out because it came too close. Like chances are tons of planets were shed out of the solar system in the early history, and that would contribute to the rogue planets out there. But to get two in perfect gravitational balance as a binary object out there, that is a puzzling mystery.
Yeah, and then the majority of these other ones that we were finding, again, they had velocities consistent with the stellar velocities in these clusters. These were not high velocity planets. So suddenly we had a really cool dynamical mystery. And this let the theorists do cool stuff.
Do we have a comprehensive theory on We do? Okay. All right.
So
I didn't think we had, but I'm
it
ready
came
to
out
hear
either
it then.
last week or 2 weeks ago. It's a brand new paper. And it's it came from the Chinese Academy using JWST data. And what they did was they modeled the interactions of circumstellar disks of systems that were flying near one another, just like galaxies might fly near one another. And just like galaxies will form bridges of material as they sweep past each other in galaxy clusters, they found that circumstellar disks sweeping past each other at like 3 to 4 kilometers per second in these star-forming regions will create bridges of material, and the dynamics of these bridges of material will cause two knots to form. That will develop into two binary planets.
Wow.
And
So hold on. So you got two star systems that move past each other. You get this bridge of material going between them.
Yeah.
And then that sort of turbulently makes two binary planets to be able to be extracted from this system, and then they float off in their own direction.
And because the kinematics of it is you have two solar systems going past each other, 3 to 4 kilometers per second, they both transfer momentum to the planetary system that forms these jumbos, and they end up with velocities consistent with the motion of the stars in the cluster instead of being high velocity planets. So they were able to explain the binary formation, they were able to explain the velocities, and of course they can also form singular planets through this mechanism and still get the right velocities. Yep. So it looks like there's two different methods for these forming. The two solar systems pass in the night, and violence within one solar system.
Right. And there was like another theory that was like the alternative, which was that they just formed in place. That if you have enough material that collapses down and you get a
failed brown dwarf
stuff. Yeah, you get a failed brown dwarf, which is already a failed star. But the problem is, how do you get enough of the heavier material to form something like that, and for it to be able to remain? So there's one theory that I'd reported on that I really liked, and I don't think anybody's really put a lot of credence to it, which is that they were actually bigger before, maybe even stars, and that the combined radiation of the Orion Nebula sandblasted them down to jumbos.
And one of the arguments I saw in a different paper was you can also end up with the shock waves of supernovae blasting into each other. And in this shock wave of heavier mass material, higher atomic mass material, atomic number material rather, you can end up with planets forming at these junctions of shock waves as well.
Yeah. But I think, just seeing, like, it shows you, it's like this new discovery is made. You're finding all of these planets. Suddenly you're finding that they come in binary pairs, and then the theorists get to work.
Yeah.
And they try all the different ideas, and then we will get to the scientific consensus. And so I think for a lot of people who are, we're here thinking about dark matter, dark energy 100 years, 50 years, 20 years after these observations were made. You're not there for that back and forth as astronomers work their way through the troubleshooting tree, right?
Yeah.
But with this one, you get to watch it in real time. You probably remember when these jumbos were announced just like 2 years ago. And yet here we are now. They're working their way through the possibilities. They're making more observations. They're rejecting ones, doing the simulations, and we will get to the scientific consensus of how they form. All right, I want to sort of continue talking about rogue planets, but it's time for another break. And we're back. So then what would one of these rogue planets be like if you could fly your spaceship to one of these systems?
Yeah, I'll go with system.
Yeah.
So it in part depends entirely on the mass and the age. These are things that start out with the heat of formation, the heat of gas that gets compressed. And initially, you can end up with a system that is warm enough through some combination of contraction and decay of radioactive materials inside of it, that it might even be warm enough to have very lazy life. Now, you're not going to end up with anything that requires sunlight, clearly, but the kind of life like we see down in the Mariana Trench could potentially exist if it evolved fast enough. And that's the problem, is this stuff isn't getting regularly heated by a star. And in a star-forming region like Orion, you do have all of these O and B stars that are massively heating things up, that they might flow in and out of the range of getting blasted by these OB stars, but you can't count on it. And once several million years have passed, you no longer have a dense open cluster. You have something that's opening up more and more. Billions of years later, it's no longer even a cluster. And now you have a cold, probably dead world as those radiation decays run out, and you're left with a chunk of daughter atoms and coldness.
But what about moons? Do you think these rogue planets could have moons?
They could, depending on their formation mechanism. It looks like the jumbos could have moons. It looks like the ones that formed in shocked systems could have moons. It's unclear about the yeeted ones. That depends on the dynamics. But it's possible, and those moons are going to cool off even faster because small things cool faster, as we all learn from making pies of various shapes.
So then, there was, we talked about the Haitian worlds.
Yes.
And so one really interesting possibility is that if you do have like a world with a hydrogen atmosphere that is a moon of a gas giant, for example, then that delivers enough energy. Like if you think about Io, right?
Yeah.
Imagine if you surrounded Io with water and an atmosphere, it would be warm. It would
Tidally,
be dark,
yes.
but it would be warm. And so you could find this sweet spot where you've got this planet with enough internal heat that is able to keep its ocean warm. It's got a thick hydrogen atmosphere that's keeping its water liquid at the surface. And you would have a world that is not receiving sunlight, but is as a liquid surface. And so there's some really interesting possibilities for these planets. Obviously, not having sunlight is probably a deal killer in a lot of situations. But still, I think there's our imaginations start to open up as we think about this. Do we have a sense then of like how many are out there?
We do. I do want to add one thing to what you just said. You have to have multiple moons or the orbits will circularize over time. So it's key.
You need those.
Yeah, you have to create an elliptical orbit to get those tidal forces going. Now, given the number of these that are potentially out there, I see space for that to exist. Depending on what paper you read, and I love the chaos of how many they do or don't think are out there. So for context, there are 100 to 400 billion stars in the Milky Way. Depending on what paper you read, there are anywhere from 4 times on the conservative end to 100,000 times on the, oh my God, planets end.
Yeah.
More planets than stars. The typical number I found was billions to trillions of rogue planets in the Milky Way.
So more than stars.
Yeah.
Yeah. And hold on, I want to just quickly, could that explain dark matter? And the answer is no, because when you consider, say, the solar system, the sun is 99.8% the mass of the solar system. And so you could have thousands of other Earths inside the solar system, and it still wouldn't be of much mass compared. More than half of that mass is Jupiter. So you could add a lot more mass to the solar system, or a lot more planets, and it wouldn't contribute to the mass of the solar system. It wouldn't account for dark matter. So, but I love this idea that when we look out into space and we think about the kind of interstellar gulfs that we would need to cross to go to the nearest star system, there could be hundreds or maybe thousands of rogue planets in the gaps in between us and that nearest star. That there are, if we can get the timing right, that there could be gas stations out there filling the void that we just weren't even aware of 10 years ago.
You still have to steer for them. I mean, the thing is that, they can be out there, but it's just like every time we send a probe out through the asteroid belt, we have to make sure we point carefully if we want to visit just one asteroid.
Yeah, you don't have to avoid the asteroid belt. You have to aim for them.
Exactly. And so it's going to be something similar to that if we're able to ever do a really solid census of like what's out there between us and Alpha Centauri and other nearby-ish stars.
Yeah.
Sure, there could be some out there, but we're going to have to aim for them. And doing that census is so hard, but this is why we need to just keep looking up, keep doing projects like Ogle that are looking for all these microlensing events, keep building infrared telescopes, and hopefully we'll turn up more and more as our telescopes get larger and larger over time.
And so can you foresee this time when we have, I mean, I wonder, like, we probably won't be able to directly observe them until our telescopes are monstrous.
Yeah.
But we will, with this gravitational microlensing, we'll build a better survey of what's out there and around us.
Exactly. And knowing how many to look for starts justifying the funding. And that's one of the frustrations is all of this, like so much. Science advances along 3 different axes: human creativity, technology, and funding that goes into funding the humans and the technology.
Right.
And right now we're looking at massive budget cuts to the National Science Foundation in the United States, potentially a 50% cut coming to NASA's Science Mission Directorate funding. And that slows down the advancement of science and ultimately reduces how many people choose to go into science and are able to stay in the field of science. So, yeah totally possible. Need more money.
In the U.S.
And sadly, we are one of the major by dollars places that money is getting spent just because we're big.
That's interesting. You know, I think I'll do some research into what is the state of space research around the world and how that compares. Because like
China's defeating us right now.
Yeah, like China's just releasing an enormous amount of science. Like now when I look through archive,
China. The Chinese Academy of Science is doing amazing work.
There's a lot of Chinese-based, research, but here in Canada and other places, it'd be interesting to sort of sense how that is starting to change. Because if the U.S. is literally taking its eye off the ball in terms of space science, you're going to see places like China and stuff fill that gap. So it'd be interesting to sort of see if I can catch that transition in live. But anyway, we're off topic now. Very cool. One of my favorite topics, Pamela, rogue planets. Thank you so much.
I love this, and we were able to do this thanks to our patrons. This week, I would like to thank the following humans. After I cough, I'm so sorry. Rich, you're going to have to edit. Okay, this week I would like to thank Sergio Sancevero, Bill Smith, Brett Mormon, Jarvis Earl, Slug, G. Caleb Sexton, Andrew Moore, Evil Melky, Bresnik, Andrew Allen, Cody Ross, or Rose rather, Brian Cook, Robbie the Dog with the Dot, Kate Sandretto, Helga Bjorkog, Stephen Veit, Christian Megerholt, Andrew Poelstra, Gerald Schweitzer, Zero Chill, Les Howard, Gordon Dewis, Kim Barron, Katie Bairn, Masa Herleu, Alex Cohen, Matt Rucker, Antisaur, Stephen Coffey, Michael Regan, Diane Philippon, Philip Walker, Sean Matz, Cooper, Sam Brooks and his mom, Jeff Wilson, Matthias Hayden, Cami Rassian, Scone, Glenn McDavid, Tim Garish, Robert Cordova, David Bogarty, John Thays, Christian Golding, Frank Stewart, Time Lord I Rowe, Jim of Everett. Thank you all so very much, and we will be here next week.
Thanks, everyone. See you then.
Bye-bye. And then they saved. Are you going to watch the NASA Town Hall this afternoon?
Sure. I didn't know what was happening.
It's out of LPSC. If it goes live on YouTube, I'll get you the link. I'm probably going to, if it's on YouTube, also do a watch party on Twitch.
Yeah, probably not. I'll just read I don't have time to watch these things live. I'll just watch it at 4 times speed. YouTube has increased the ability to watch videos fast up to 4 times speed.
I can't do it.
Oh, I love it. 4 is tough. 3 is doable, but if I'm reviewing my own videos, I'll do it at 4 times speed just to make sure that I didn't make any big mistakes. It's a huge time saver because I can watch a hour-long interview in 15 minutes. It's awesome.
Yeah, my brain is just like, no, they sound like chipmunks, and just yeah.
Well, it's even corrupted my brain because I'll watch my videos at normal speed for every now and then I have to, and I just feel like I'm talking so slowly.
Yeah,
Like I'm
Kyle
like I'm
watches
drunk.
everything high speed, and he can't watch regular movies without getting twitchy now.
Yeah,
And
yeah,
it's just sort of like,
yeah. What have
but
we done? What have we done to ourselves? Oh, yeah.
yeah,
I listen to all my podcasts at 50% faster, and I generally watch YouTube's videos at double speed.
yeah, my
Yeah.
brain.
So I want to understand. Ava said I got directed to a Universe Today robot YouTube channel, and it was obviously not you. Good luck. I'd be interested to know what that was.
Yeah.
So is that somebody is pretending to be me? There you go, Zaphan. Rouge planets. We're not talking about rouge planets, Zaphan. Talking about rogue planets. It's so funny that just happens all the time. Um, and Zaphan says rogue planets might not be gas stations, but might be useful for gravity slingshots and bending trajectories. Yeah,
Yeah.
absolutely. I mean, that right now, when you think about interstellar travel, it's how much velocity can you get leaving the solar
Yeah.
system, but you build up your velocity using gravitational
Hmm.
slingshots. And so imagine if you could put together this trajectory that takes you past a whole bunch of rogue planets between you and the destination, and you get gravitational slingshots from each one. They're all useful. Yeah, I love that.
Europa Clipper did a gravitational slingshot of Mars, what, a
Yeah.
week and a half ago?
Yeah, yeah. And they
And
actually slowed themselves down and changed their trajectory.
and they're
So it
heading
wasn't,
back toward Earth to get another, in this case, it will be a boost.
yeah, this time it's a boost. Yeah. And so you can go either way. You can use
Yeah.
a gravitational slingshot to slow you down, or you can get a gravitational slingshot to speed you up.
I am deeply amused. Broken Symmetry wrote, asteroid belts won't keep your pants where they belong. You may need asteroid suspenders.
Jeff Harris is saying on Google, you can add -AI at the end of the search to skip the AI gloop. That's good.
Oh, that is very good.
Yeah. But like, who's going to do that? Nobody's going to do that. Everyone's just going to use it, and then they'll see the answer that they want. And, like, I do it. I'll do a search on Google. I'll see the answer. I'm like, oh yeah, of course. That European time is offset by Pacific time by 10 hours or whatever. Like,
So for things like that, it's fine. So like one of the things I run into issues with all the time is I have this absolutely stupid latex allergy, which means I'm allergic to every plant that has the same protein that the rubber tree has, which includes like the skin of tomatoes. And so when I encounter some new fruit or vegetable I haven't eaten before, I'm like, is this plant cross-reactive with latex? And the AI always, no matter what, says yes, yes it is. And it just defaults to that because it will find an article that lists the plant, says latex allergy in it somewhere, and assumes yes it is.
yeah.
And there's other stuff like that that I hit all the time. So, yeah, me and the AI hate one another.
Donnie Rasmussels asks, will Vera Rubin or Nancy Grace Roman find more of these?
Yes.
Yes and yes. Yeah,
Both.
they're both perfect for this.
Yeah, it's going to be like Rubin is going to change things so much that we don't even know how much it's going to change things. It's like the Sun Digital Sky survey completely changed our view on the shape of the cosmos in terms of the distribution of galaxies, and now the Dark Energy Survey instrument is taking that one step further. With Rubin, it's going to be mapping out the minor planets in our solar system, cataloging transient objects that are flickering, flaring, pulsating that we didn't know about.
Yeah.
So anything that moves or varies in brightness, we're going to have an entirely new census of.
Yep. So last week we heard rumors that there was a 50% cut coming to NASA.
Yeah.
It
This is
hasn't
why I'm
happened
watching the thing this
yet.
afternoon.
Yeah, it hasn't happened yet.
No.
So what is what is the rumor? It's not just a straight, like, NASA used to get 22 billion and now it only gets 11 billion. Is it that, or is it specifically cuts to their?
It's the Science Mission Directorate, which is the part that funds science exploration. So Hubble, JWST, grants to do research.
Europa Clipper, so all the
Dragonfly.
Is planetary separate from the?
No, so planetary, astro, helio, and Earth science are all part of Science Mission Directorate.
So it's just not aviation and human space exploration.
And R&D. R&A is what they call it.
Yeah.
And
but like, of course, the Artemis mission is going to go under the knife.
So here's the thing. Artemis is not in jeopardy as long as Starship keeps blowing up. Because right now, we don't have a reliable super heavy lift vehicle. Blue Origin is competition for Falcon Heavy. But for that truly heavy lift vehicle, SLS is all we have.
Yeah.
And the intriguing thing to me is, we see this all the time, especially with the New York Times. Biden does something, oh my God, he's so old and decrepit. Trump does the exact same thing, he's amazing. There is a lot of bias in reporting and spin in reporting. So SLS, the first Artemis mission with the Space Launch System, was deemed a partial failure because they had a minor issue with one of the heat shields.
Mm-hmm. Yeah. Yeah,
where
it was delaminating when it was coming back through the
atmosphere. And then we look at how they talk about Starship because it's incremental design and they can destroy air traffic twice and it's still a good program. So the way things are getting spun in the media makes us feel that Artemis is a failure, and it's stupid expensive and budgetarily.
Yeah. Yes, right. I mean, I think, like, in the best possible situation for Artemis, that it works perfectly, that there's no delays, that Starship is ready to deliver astronauts to the surface of the moon. This thing costs $4+ billion per launch, and that is not sustainable.
And as soon as Starship works, it's dead.
So as soon as Starship is operational, but is human rated and can deliver from Earth to the moon and back again, like, that's a long list of things.
And they're already 2 years behind on HLS, and they haven't even developed HLS yet. And they announced yesterday, I think, that they're not going to try and fix Starship with the Raptor 2 engines. They're going to wait for Raptor 3. So the next flight of Starship 9, the plan isn't to try and orbit Starship. The plan is to refly a booster. And they've nailed the boosters. I have no complaints about their boosters, but Starship disrupting air traffic in a way that is dangerous to civilians from multiple nations is really not good.
But let's imagine like I said, the best possible version is, or I guess, for Artemis or for the Space Launch System, is it works perfectly.
Yeah.
And yet it's unsustainable because it's too expensive. And so how can you continue down that road building that thing knowing that it's living on borrowed time, because I don't think depending on Starship is the way either. Like as you said, I mean, it's an exciting technology. We've seen the booster catch. That is clearly a path to reuse.
Yeah.
That's an amazing part of that puzzle, but the top part still hasn't been dialed in. Orbital refueling has not been demonstrated. That there is a different architecture.
Yeah.
Like if it is a priority, then there needs to be a different architecture for sending people to the moon, and nobody is pursuing that different architecture. You've either got people going, well, let's just keep building SLS because that's what we do, or people saying, well, let's just cancel SLS and let's go to Starship. Neither of those are going to provide
No.
that goal.
And
If you lose the goal.
There's a different issue that's more fundamental. That is why we are trapped here. NASA went from being full cost plus fee contracts, which led to JWST being completed for billions of dollars more than it costs on paper when they first decided to do it. And NASA footed the entire bill and they got a fully functional JWST. Now, they have in recent years switched to a flat fee budget, which works for things that are utterly reliable, like going to LEO. Mm-hmm. So that is proven technology. We know how to do it. There are multiple rockets that can get to LEO, no big deal. Rocket Lab delivers stuff left and right. Starship delivers stuff left and right. No big deal. Not Starship, SpaceX delivers stuff left and right.
Yeah, Falcon 9s.
Now, the problem is that historically, no one has ever budgeted correctly how much it's going to cost to develop new technologies. So we have companies that are essentially bankrupting themselves and going out of business, trying to figure out how to deliver commercial missions where NASA is one of their customers and isn't picking up what it actually costs to deliver stuff. And so
I have a plan.
Okay, I want to hear your plan.
Sure. So we saw the failed landing of Intuitive Machines 2 of the Athena, followed on top of the failed landing of 1, Odysseus. But we saw the successful landing of Blue Ghost.
Blue Ghost nailed it.
And
Firefly Airspace.
Firefly Blue Ghost.
Amazing.
And we see them vacuuming on the surface of the moon. We see them drilling, like it's doing its science.
Yeah.
And then that was under the CLIPS program, which costs, they pay about $60 million for the ride to the moon.
And it's the first to actually succeed.
First to succeed, yeah. There have been many before, but this is the one that worked. And so it feels to me like the solution is you go clips, that you send a lunar lander, a private lunar lander every month, every 2 months, where you are just like astronomers, eat your heart out. Like whatever you want, there's going to be missions going to the moon, but you make them bigger. And so you scale up the CLIPS program and go, now you need, right now you only have to be able to deploy 100 kilograms to the surface of the moon. I'm not sure what the CLIPS requirement is, but there's going to be some amount of mass and power requirements and so on. And then you just scale that up. And then you put in a return requirement where you're like, okay, now you need to be able to deliver 1 kilogram of material back to Earth, similar to what the Chinese are doing with their sample return missions. And you just keep scaling up so that you've got this increasingly dependable, vibrant, multi-supplier, private public integration. And then you'll know when you're ready to, if you're delivering or if you are returning 200 kilograms from the surface of the moon, you're returning 1,000 kilograms from the surface of the moon, you're starting to get to this place where that technology could be human rated and you could actually be delivering people to the surface of the moon. So
there's a big issue with this.
I'm ready.
So right now we have had all these companies, Astroforge, Astrobotic, Intuitive Machines, Firefly Aerospace. There are many others that I'm forgetting the names of that have found the venture capital that has allowed them to vacuum clean up individual wealthy people's money and consortiums of wealthy people's money to throw hardware at the moon and fail miserably. Peregrine didn't even make it to the surface before it failed.
Yeah.
At a certain point, venture capitalists are going to say, and we are done now. And so we are at the point where in order for hardware to make it to the moon, because NASA is just dangling treats, not actually paying for the launch, you're going to have people be like, yeah, no, this is not profitable. Even SpaceX, they're making their money off of Starlink. They're not making their money off of their launches.
Sure, but if you're building up a sort of an industry, and you're saying, okay, if $60 million isn't enough money, then it's $70 million, then it's $80 million. It's not. It's the iterations that are what matters. That the problem with Artemis is it's $4 billion. Well,
Yeah.
what would $4 billion turn into if you broke it up into what is that? 40
But
$100 million missions to the moon?
you're just shifting who's paying for it, though, in a lot of cases, because you're going to have a lot of failed missions that are millions and billions of dollars. So take Viper. If Viper got pulled because they realized they were going to drop $1 billion worth of expertise and hardware on the moon, and it was most likely going to fail.
Yeah.
So they're like, no, we shall not.
Right.
So you're shifting the money from being taxpayer money to instead being venture capitalists' money. And I feel like venture capitalists are going to be far less likely.
I 100% disagree with you.
Okay.
Yeah, I think that if now that Firefly has delivered Blue Ghost to the surface of the moon, did they lose money? We'll find out.
Oh, yeah, they lost money. The question is, their stock is doing well. Intuitive Machines could easily go bankrupt off of what happened.
Yes, right. Because they got two failed landings in a row. So I think I think right now, maybe the amount that they're paying is too low to really make it worth the while for the venture capitalists, for the companies to do this. But I don't think that we're off by 3 orders of magnitude.
No.
I think we're off by 50%. We're off by 100%. That if instead the CLIPS program is paying $100 million, maybe the CLIPS program is paying $150 million. Like you're going to get to this place where it is worth it to NASA and other international partners to deliver payloads to the surface of the moon. You're subsidizing this, and at the same time, you are, through many different people, working out what is going to be the most effective way. In the exact same way that if you want to buy a car, or if you want to take an airplane ride, there are multiple airline manufacturers, different routing systems. There's all, it's a vibrant network. And so I think that on the one hand, you build the giant cathedral that's too expensive for you to keep going. That's not going to work.
No.
And then on the other hand, you put all your eggs in the SpaceX moonshot basket. That's not going to work.
No.
I mean, maybe it'll work if you're lucky, but probably the thing that's going to work is going to be the solution that nobody was expecting. And the only way you do that is if you roll the dice a lot and give a lot of people a chance to try and step up and solve
the CLIPS mission isn't funding rockets, and that's where we're stuck. We need someone to come up with a super heavy.
Well, yes, but we have the Falcon Heavy. We have the New Glenn. So those gaps are starting to be filled in. You've got Ariane 6. You've got everything that the Chinese are doing. So I think that there's a lot of heavy lift capability that there hasn't necessarily been the demand. And so what NASA does is NASA says, we'll pay you $200 million if you deploy 1,000 kilograms to the surface of the moon. That creates the demand. And by paying $200 million, you could pay for, with a $4 billion, instead of a $4 billion rocket, that allows you to pay for 20 of those. And that's profitable at 200. And if 200 million isn't profitable, then you make it 500 million, right? At a certain point, that is a number that is profitable, and that primes the pump that gets this machine rolling. And right now, it just feels like either we spend the $4 billion, or we wait for SpaceX to solve the problem on their own dime, or through government funding. Neither of those sound like they're the right solution to me. Neither of those feel like they're the vibrant mechanism. And so I would, and yet watching Blue Ghost land on the moon and do its thing, that feels like that's the future. You just scale that up.
But I really wish that we hadn't built Artemis and the Space Launch System on space shuttle technology as a jobs program. I wish we had said, go forth, innovate on federal funds.
Yes. Yeah, innovate. It's the innovate part, right? Like what NASA should be paying for is innovation. Yeah. That they don't want you to be boring. They want you to be innovative. Let SpaceX, let Rocket Lab, let Blue Origin, they can be boring.
Yeah.
But we want innovation. And we're willing to pay the premium for the innovation, knowing that the new innovation that we develop will then feed back into the private industry. So we're out of time.
Yeah.
That's my rant.
Yeah. Don't look at the stock values for Rocket Lab or Intuitive Machines or Boeing. If you have invested in space industries, your portfolio sucks. Don't look.
Or anything. The entire stock market is down. Just don't look at anything. Don't look at anything at all.
It's
ever.
true. It's true.
All right. Well, thank you, everybody, for watching us today. Thanks in advance to Rich and the rest of the team who are going to be producing this nonsense and editing it down into something that people will actually want to listen to. Thanks to the moderators who weren't busy, I think, today.
Yeah.
Thanks, Pamela, for bringing your vast astrophysical knowledge. We appreciate it.
And thank you, Fraser. And I am so amazed with what you did with Universe today. And I'm glad you are once again pioneering the way forward for the rest of us.
We'll see what happens.
All right.